Hello, everybody. How's it going? Just checking my mic is working. It looks like it's working. I've got my little meters are bouncing up and down. I was thinking about what kind of rap to do today, but I was up late last night getting the lecture stuff ready. I think I need some kind of tool that helps me do rhyming. That's what the demo is today. But anyway, strings and things. And I couldn't think of anything in time to rhyme with strings and things, but I've got strings and things and rhymes and time, and so maybe there could be something I could make out of that. But I didn't necessarily put a rap together for today. Got some interesting questions this morning, though. So Dan was asking in there, what happens if I pass all the auto tests? Do I automatically win if I've passed all the auto tests? So I'm showing you a very extreme example of how I could write code that says what is the input that comes in from the auto tests, and then I spit out the correct output. So it doesn't do any of the processing that we're supposed to do. It doesn't fit the specification at all. It just reads the input and then spits out the right output. And that's what happens if you get too focused on the test. Because that's the idea of like just sort of hard coding answers, and we don't really want that, right? Because then we pass the auto tests that are absolutely nothing else. So if you're passing all the auto tests and you know that if those auto tests switched around to test you in different ways, you'd still pass them, that's pretty good. Also, particularly if you've gotten to stages 4 and 5, there are gaps in the auto tests. There are intentional gaps in the auto tests because we think if you're pushing, especially into stage 5, so stage 5 is like you're trying to get your mark from 90% to 100%, which is only I think approximately 10 to 15% of students may attempt that stage at all. So if you think that you want to show off to that level where we're taking the training wheels off at that point, and you're gonna have to do it on your own. So you have to look at the spec, and you have to think about how the auto tests would look if they were comprehensive, and then you do them yourself. So there's that difficulty there as well. There was another question there. Eric was saying, if we're still doing the assignment, should we be trying the weekly challenge exercises as well? Eric, there's a few ways to look at this. We can look at this as in terms of like, what do we need to learn? And we can look at this in terms of where do we get our most marks. I've usually put the most marks in the places where it's most important to learn things, which is more the assignment than the challenges. In fact, the challenges, if you've completed all the core questions in a lab, the challenges are basically worth nothing. They're only worth something if you haven't completed the core challenges. Not challenges, the core questions. So I would say that if you think that there's stuff to do on the assignment, I would focus on the assignment. The weekly test, I would potentially just leave. Because the weekly test we've just released is not due until week 7, so its due date is after the assignment's due date, so I wouldn't even bother with that. And the lab you can still do if you want to. So it depends on whether you're interested in those challenges or not. So in terms of learning stuff, if you think that you're not learning much more in the assignment, you know what you're going to do in the assignment, it's just a matter of time to get it right. Then you can put more effort into those challenges if you want to try to learn something new that you maybe haven't seen before. And William is saying, but if you don't know how to do the core questions in the lab, how are you supposed to do a challenge question? Yes, there's no point doing a challenge question if you haven't done the core. But sometimes the challenge questions follow from some of the core questions and not from the other core questions, so you might be okay on one part of it and not the other. It's usually just the challenges are if you slip up or if you miss a lab at a different point in the term. Then so it's not just, sorry, the way I said it earlier made it sound like it was within that lab. If you've got bonus marks in some of the challenges, it means that later on in the term or something, if you're like, I got sick and I couldn't finish the entire lab for that week, then the challenges can make up that loss of marks. So there's like those little calculations like that may or may not help. It's still not really necessary though, because we've even got a buffer in there in case that kind of thing happens, where we will only mark your best, I think it's 7 out of 8, 6 out of 7, or 7 out of 8 labs. Yeah, there's 8 labs, and so you could miss one entirely because you're sick, and then you don't. Then it won't be a problem. Miguel, yeah, the challenges kind of add up to this sort of extra bonus pool of marks, and the bonus pool of marks can be just kind of pulled in anywhere you miss marks elsewhere. I'm pretty sure that's the case. I would have to check with Tom about exactly how the code is counting this up, but I think so. Yeah, and what Girichan is saying is like sometimes because the difference between the most difficult question in the lab and the first challenge question is only a small step. So sometimes you can actually do the final question in a sometimes the final question of the core questions is difficult and the challenge is easier, because it's just like, they're slightly different topics. They're not always going to be the same, like it's exactly the same knowledge going from the core questions into the challenges, because it could be like, for example, recently we're looking at two-dimensional arrays and functions roughly at the same time, and so you might be like totally on top of how the arrays work because they're an extension of the 1D arrays, but you're not totally on top of how to structure functions and when to use them and things, and so one of those questions might end up easier than the other. Paco is asking, will the challenge questions appear in the final exam? Yes. They won't be listed as challenges, but when we think about the difficulty level of which we want to check where everyone's up to, we know that there is a percentage of the class that is capable of doing challenges reasonably consistently. And so in the exam, we need to assess everyone, which means we need, like, a perfect exam. The way that an educator writes a perfect exam is that everyone in the course gets a different mark in the exam. So if I write the exam with no questions of the difficulty of the challenges, then we end up with a situation where a significant percentage of the exam gets 100% and I can't tell them apart. The exam's supposed to assess everyone, which means that everyone gets a different mark so that I know where everyone sits. So yes, we need questions of the difficulty of the challenges in order to test where everyone's up to. Yeah, and Ethan's saying that there's not as much consistency in the challenges in general. So some of the challenges are abominably difficult, and some of the so some of them are just there to get your brain going, and there's actually no intention that anyone can solve them. And some of them are there for a lot of people to solve, so that they can see a slight difference in how things work. Yeah. Okay, let's get into the lecture itself. I mean, it's good conversation and stuff like that. You know what I might try to do next week, because we don't have official lectures, is maybe have a session where we just sit and talk, and then you can ask me questions and stuff like that. Yeah, Miguel, decimal spiral is probably one of the hardest things in the course. I'd rank it alongside the difficulty of some of the late stages of the assignments as well. So that one's really just to get your brain juices flowing. I don't intend for everyone to solve it. And I think if people go in thinking that they should solve every single question in the course, that's a bit much, I think. Okay. Let's move on. All right. So last lecture, what were we looking at? We were looking at debugging. So we were looking at different techniques we could use to remove bugs, which is the name that we commonly use for code errors. And we looked at some of the tips and tricks, in a sense, where if you're stuck and you don't know what's going on, use those techniques first, and they should get you a little bit more information about your issues than otherwise. It's really about debugging is about systematically figuring out which bits of your code are and aren't working. Because if you can nearly grab sections of lines of code and say, this stuff works, this I'm not sure of, this works, this I'm not sure of. You can at least reduce the amount of code you have to read in order to find out what's going wrong. So it's nearly like narrowing your suspicion will get you to an answer quicker. We also looked at characters, new variable type here that stores letters. We're going to be working more with characters today. We have a little bit of a recap and a continuation on the characters we looked at last week, and then we're also going to go into strings this week. So words, or not just words, collections of more than one character at a time. And hopefully that will be reasonably self-explanatory as I show you how it works, because we're just going to use arrays of characters. And since we've used arrays already, then that shouldn't be too bad. There's just some subtlety with how we're going to use strings, because words are not a specified length. Lots of words are lots of different lengths. So excuse me. Sometimes I think I should do like a whole bunch of theater warm-up exercises before I start lecturing in the morning, because like it's not like I don't get up in the morning and then talk for ages and warm up my voice before going, and then I just launch into it. Yeah. Anyway, so because words aren't all the same length, we're going to use a special way of saying, look, we've got a big array that could contain words, and we have a way of marking where something ends in that array. So I hinted at that idea when we had when we were doing numbers in arrays, and I had like, I think it was a 0 or a -1 to mark where we finished. Strings have a specific character that allows them to do that, so it'll come in pretty handy. We'll show how that works. I'm going to show you lots of different ways of using strings today, including using libraries and stuff. So we're going to get deep. I'm going to go deep into it. And we're going to look at command line arguments, which is a different way of us giving information to our program. So, you know the line we type in when we start our program? We go /program name. You can actually put stuff after that. So you can put words and numbers and stuff after that and have them actually be passed into the program. So this is actually going to be the first time we're not writing int main void, because our main function will now have inputs. They come in a very specific format, but I'll show you how that works. We'll put that in the example today as well. The example today is like, it's a little bit contrived. Like, it's like, I'm doing a thing which is it's like a rhyming dictionary, but it's a program that tells you if a word you type in rhymes with a line that you've typed in, only it doesn't really work that well. It's mostly like, I just wanted to show all this kinds of code, and this was like a theme that I could loosely wrap around it, but we'll see when we get there. I left it as a challenge for people to see if they can make it better than it is, because writing a program for actual rhyming is really, really difficult, because words as they are written as sequences of characters don't always actually imply how they are spoken and what kind of sounds they make. So take the rhyming program we're writing today with a pinch of salt. Okay. Oh, Rosie's asking if there is scaling in this course. There is no scaling in this course. Your marks are raw. So if you want to, when you finish with the first assignment, you know roughly where your lab marks and your test marks are, you can actually, it's actually not that bad a prediction at that point to look at the percentage of marks you've gained and lost, and you can nearly predict that the final result's going to be roughly that if you continue with the same amount of effort all the way through. So usually people's assignment marks are reasonably similar to what their final mark is going to be. It depends. It really depends on what your situation is at the time, though. Okay, so recapping and continuing with characters. So we saw some of the stuff that we're doing with characters. Remember the weirdness of using an integer for a single character. So a lot of the time we'll use an integer for a single character. I mean, sometimes we'll use the character variable, but most of the time the character variable type will actually only be used when we're using arrays of these. And we'll use an integer for the single one because there's a few things we can do with integers to, even as we're representing characters, there's a few things we can do with them that we can't do with the character variable. So it's a weird little thing that we're going to do here, but it sort of works. If we want to, we can print out a character as a character, and then it will convert it to its letter, which is A, or as a number, and it will tell you what the ASCII value of it is. So we're not too worried about ASCII values. We don't actually need to know what they are. We don't have to memorize them, because anytime we need it, we can just say, please store this letter in this integer, and then view it as an integer, and then you'll get the ASCII value. So you don't have to memorize it, because you can always get it using your code. If we want to print out a single letter, the %C is a new thing that we can do with printf. Get my face out of the way there. We have a few functions. A lot of these come from the standard input-output library, but we will also see that there are other libraries that we can use for characters. So last week we had a quick look at least at getchar and putchar. They are a little bit similar to things like printf and scanf, which were capable of, if we wanted to kind of thin them down, we could use them for single characters. The only difference being that getchar and putchar will work with actual individual characters, whereas scanf and, well, printf doesn't ignore anything, but scanf will often ignore white space. So if we use getchar and we put in a space, we're actually going to get the character for space. But if we use scanf and put in space, scanf will ignore it. So there's sometimes reasons to use either one. If you want to take really, really raw input, so if I was taking input for, I don't know, like a computer game or something like that, I'd want to use something like getchar, which would give me the raw key inputs. So, like, for example, a lot of games, the spacebar is used to jump. And if I was scanning F or scanfing, I don't know, all of my input over and over again to see whether people were pressing buttons, every time they press space, my scanf will go on, and that's just a gap between things that I'm looking for. I won't bother, and so it won't necessarily pick that up. I think that's the case. Actually, I wonder if you do scanf with %C, whether that works or not. I love how I talk about these things sometimes, and I say, well, I'm so used to doing it with something like getchar that I haven't actually plumbed the depths of what scanf can and can't do. But usually, this is the way we'll do it for individual characters. I mean, you can also do this if you want to with printf. It's going to be reasonably similar. We had some examples of getchar and putchar. We're gonna have a look at these more today. We're not necessarily going to use that much of it, but in the example today, later on in the second half of the lecture, we will use some getchar, and we'll look at some of the details of getchar as well, because getchar also uses uses this code, which is EOF. And EOF is usually defined in most of the standard libraries that we can use in C. It's defined in the standard input-output library as -1, usually. I won't say exactly what it is because we'll use EOF, but I think it's usually the same thing. And that says that getchar, when it tried to grab input, couldn't get any input. And that's another reason why we use an integer, because the character can't do negative, but the integer can. So if we getchar into an integer, we can get an error code, and that'll let us know whether things are working or not. However, it is actually quite easy to go back and forth between integers and characters. If a function, for example, wants a character as input, we can actually give it an integer as input, and so long as our integer doesn't necessarily overflow the 8 bits of the character, so it's between 0 and 254, I think is the values, then it will still actually work like that. Okay, we also saw a little bit of characters that we hadn't necessarily seen before. So new line as a character, space as a character. The EOF is kind of considered a character as well. So all of these things can be picked up by getchar, and each of them also has its own ASCII code. So them having a number code means they can be stored as a character, and they can be used as characters. I mean, this should start to become sort of reasonably apparent to you when you think that something like printf was going through character by character and putting that stuff on the terminal. So when there was a gap between words, it needed some way of telling the terminal, hey, put a space here. Or the user wants to go down to the next line. We need to tell them that they can go down to the next line, which means if each of these things was going through as a number that the terminal was going to use to do something, then there needed to be a number that would represent a new line and another number that represents a space. We had a look at that yesterday, so if you want to look at the end at the demo, there was a little bit of me typing stuff into this code here, which was... Oh, actually, I don't think we did it with a loop. I think we just did the single one, which was like enter a character, and it was like this character has this ASCII value. And we saw that enter and space also had those ASCII values. Yes, Miguel's doing the maths there, showing in chat, you can say 2 to the power of 8 minus 1. So 2 to the power of 8 is because the characters are 8-bit values. The minus 1 is because one of those values was taken up by 0. So 0 to 254. Rosie's asking about how to use EOF. There is actually, you can actually assume there's a hash define in the standard input output library that says all capitals EOF and then has the value that it's being used as. Generally -1, but I wouldn't trust it because it's, if you've got a hash define, the whole point is to use the hash define, not necessarily to think too much about the value itself. Yeah, as Shrey is saying there, it's a hash define in standard input output. I think it's a hash define in other libraries as well. Okay. I've talked about invisible characters. Okay, working with multiple characters, I think that we didn't get up to this last lecture, so we've gone from recap into new material here. If I wanted to read multiple characters in, I could do a while loop like this, and I could get char multiple times in that loop, and then just read these characters one after the other like that. So this is a little bit similar to how we were using things like scanf previously and saying, if scanf didn't get the right number of inputs, then I would stop my while loop. This is slightly different, which says because you can only get one character at a time, we only have one symbol that tells us we didn't read correctly, which is the EOF. So what we do is we say read in a character. If that character is not the end of file marker, then it is a character that we can use so that we can do something with the character. And then we read another character. So this means if multiple things have been typed into standard input, we read the first one there, and then we read the second one. After we've read the second one, we check whether it's a valid character. If it's a valid character, we can do things, and we go on. So that's a way that we could use something like get char in a loop. So we start thinking about this function get char is going to tell us whether it succeeded or failed. And if it succeeds, we continue. If it fails this condition here, and we don't continue. Oh, hello there. Our lecturer in charge has just dropped in to say hello. I think she's a bit snoozy at the moment. She was very talkative earlier today, but right now I think she just wants a nap somewhere warm. So Rosie, we're talking about the end of file. Control D is what we use when we're typing in the terminal to get EOF to appear, in a sense. So when we think about it like that, both getChar and scanf are going to see a control D as an EOF. And Eric is also asking, does not equals EOF work for scanf as well? Yes, Eric, it does to a certain extent. So we can check if something is not EOF for scanf, but you can try that actually. Try putting not equals EOF into your scanf code and then type in something that doesn't match the format string. So if you're reading in numbers and you type in letters, scanf is going to return how many things it successfully read, which is 0, which is not the same as EOF. So what happens with that scanf is you may get a loop that goes forever and never reads any input because it keeps coming up against those letters and not reading them in, and then they just stay there ready to be read in again and again and again, which you may have seen scanf that goes forever because it's not picking up the type of thing that it wants. Jamie's saying, is an accidental curvy bracket instead of curly in the third last line. Oh, this one here. This is actually us doing the printf. This is me saying my printf needed to be done on multiple lines, and so what I do is I use this bracket here as if it's laid out the same way as the curly brackets, but it's a single bracket. Sorry, it's a normal bracket that I'm using there. Yeah. So this is just if I think my printf is going too long, which at the moment it would be. It's too big for the slides. If I want to do it on multiple lines, I can do it in the same format as a while loop or if statement, and I find that way it looks more consistent. So you can read it in a way that makes more sense to you. So this is one of the ways that I will split something into multiple lines. Raman's asking about ASCII codes. They are a number that represents a character. I don't really want to say more than that about it because I don't think you need to know that much. It's good to know that characters can be represented by numbers, but you don't need to know that much about ASCII. Okay, let us continue. There are many more functions that we can use for characters. So here we have a library, and it's called ctype.h. This is a library you can use via hash include, and there's lots of little things that we can use from that library. So here are some simple things that we could use. We can actually ask if a character is a letter or not, and this can be really handy if you're saying, I want to read the words that people are saying, but I don't want to read all the like spaces and new line characters. You could think about it if you wanted to, that if you were to write something to process characters and it was meant to replicate what scanf does, you could say something like scanf is looking for a number here. So you could use isAlpha or isDigit to go through and remove the things that aren't numbers and then process the thing at the end. So you can kind of imagine that maybe, I don't know if this is the case, but maybe getChar was written first, and then several years later someone said, I just want something that has more capabilities than that. What if I combine getChar with isAlpha and isDigit and these %s, %d, %lf strings that we have, also %c and stuff, and what if I build up this thing called scanf that uses all of these other functions? You can nearly think of it like that. There's all these capabilities sitting in there that are sometimes combined into other functions here and there. So if you want to, you can look up ctype.h and see all the different options that you have for working with them. Okay. Oh, check questions. Oh. People are talking about learning Unicode. ASCII is one way of doing letters, and it's a really, really old school way, because as I said last week, ASCII is actually based on your keyboard being plugged into your computer, and when you press a key, a number gets sent to your computer, and it's an 8-bit number because that covers all the possibilities that are on the keyboard. And I'm pretty sure, I don't know if this is exactly the case. I often are realizing that I tell stories and I get halfway through and go, I haven't verified that before I said it, but hopefully those are just anecdotes. But yeah, so that is actually the signal that goes from the keyboard to the computer. I don't know if they're exactly the same nowadays when we're over USB and things like that, but it's like a reasonably accepted format. But it only having 255 possible characters means it's actually quite limited in what possible letters it can send. So if you get a language that has lots of accents, so I'm thinking French, several of the romantic languages like Spanish as well, and not even starting to look at all of the languages that don't use the US keyboard layout, like ASCII. The first word in ASCII is American, so there's a whole lot of ways that we might use a keyboard that require more than just ASCII, and so there are other encoding systems like people are mentioning in chat, Unicode, that can be used for that. We're not going to go into that though. That's deeper than we can do in 1511 at the moment. I mean, we're not even going into ASCII. Like, I showed the ASCII table last week, but that was just sort of on a whim. I'd be more than happy to just never show you the ASCII table and you wouldn't need it, because you don't need it for what we're doing in 1511. We're still just going to think of things as letters, and then have ways of using them. So I usually won't specifically use or reference the ASCII numbers anywhere in my code. Someone's asking, how do we know if a number or number of letters follows the ASCII or other systems? Generally, it's ASCII. Any key on the keyboard. But having said that, we're really talking here about a very English language centric programming system where we assume that everything is written on like the standard US layout keyboard. I think if you were to switch your language to something else that was capable of creating other characters, then you'd have to be careful and look up what numbering system those characters would be in. I think C won't even be able to handle those characters, but I'm not sure. I haven't actually tried, and I apologize because like I only speak English. I speak many programming languages, but in terms of human languages, I only speak English. So I've never tried actually doing things like accents on letters in code and seeing what happens. So I'm not sure. Yeah. James asking if code can be multilingual. That's a really hard question. If you think about changing all your variable names and function names and stuff to another language, you can totally do that. I mean, like, I've taught plenty of international students, and some of them started off with putting their comments in their native language, and if everyone else is working in that same language, that makes sense. But the downside is a lot of the keywords in the language are still in English. So C was obviously written by English speakers because of words like if, while, int, double, return, so, and main. You're going to have to memorize all of those things. So it's not 100% accessible in terms of that, but other parts of it can be made to be multilingual if you want. If you wanted to, you could do things like hash defines. So you could hash define main. So you hash define a different word for the word main or something like that. It's potentially really messy doing that though, and the possibility that you break something is reasonably high if you start to do sort of blanket automatic translation of other words and stuff. This is actually a really interesting conversation, a big can of worms actually, but I'm gonna have to leave it there and go back to the lecture because I don't think we've got time to talk about it. So the next thing that I wanted to talk about is strings. So a string is the term that we use to mean a collection of characters. So this is going to be, for the moment, the way we're going to use these is an array of character variables. So strings, characters you can consider to be letters. Strings you can consider to be words. I say consider to be because they're not exactly, right? A string of characters does not necessarily make a word. A string of characters could be all kinds of things. Sorry, someone just meowed behind me. I don't actually know where she is. A string could be a word, but a string could also be a sentence. A string could be a hash key for a downloaded object or something. Like, it could be a whole series of characters. But the way that we can think about it while we're learning about it is that strings, for the moment, we're going to think about them as words and sentences. Because for us as humans, that's the most logical way we can think of putting multiple characters together. The thing that makes strings interesting, and this is exactly what I was talking about before, about them potentially being a different length, which means they won't always use up all of the characters in the array that the string is put in. So instead, they have this character, a /0. So that's a 0, not a capital O. So /0 is called the null terminator. I just love that. I love that name. I'll be back. I'll be at the back of the string, the null terminator. So it's a character, it's an invisible character, so it will never be printed to your terminal or anything like that. In fact, most of the commands that you have that are able to print anything to the terminal will actually end when they see this character. So when you say print a string to my terminal, it'll print all the characters, but if it ever sees this null terminator, it'll say, oh, that string is over. It doesn't matter if there's more space in the array. I will never read past this. And we can write stuff like that as well. So we can say we will also never read past this if we're looping through a string for whatever reason. So the null terminator says this is the end of the string, and there will be no more content for this string regardless of if there is space in the array for more content. So we won't read any further into the array once we see the null terminator. So it's a nice little thing that tells us that the size of data in memory is not fixed. The capacity is a certain size, but we may only be using part of it. So starting to use strings in code. Ethan's having a Python versus C moment here. So this is like super interesting, Ethan. So you're seeing the difference in between, what are we looking at? 25 to 30 years, I think, between the beginnings of C and the beginnings of Python. However, we will be learning stuff in C that are impossible in Python. Starting from week 7 onwards, there are things that we're doing that Python is not capable of doing. So you'll have to bear with us with the kind of weirdness that we have to do for some things in C. But C, in a sense, is nearly a more powerful language in its total capabilities. Okay. So when we were making arrays, before we could put commas between the elements of the array and initialize the entire array like that. Character arrays are interesting in that sometimes we won't actually specify the length when we're creating. A lot of the time we will, but we might have a hash defined for the largest size we could possibly think of, and then we'd fill it out only with part of it. So we could put the individual elements like here with the single quotes to say that they're a character. But we also have this shorthand here of the double quotes. You may be reasonably familiar with the shorthand of the double quotes because we've been using this since the very first program I ever showed you, which was printf. So it's interesting that we are now in week 5, and only now in week 5 have I actually shown you what the input of printf is. So we've been using it a lot. We've been using it again and again and again, and we've just been going, you just put these double quotes things in there. But now what I'm saying to you is anything in double quotes is actually the value for a string variable. And a string variable is a character array. It's really funny because sometimes these are listed as character pointers as well. And we remember the similarity between pointers and arrays. So you'll notice if you look up standard library and stuff, it'll rarely use the square brackets as the input into a function, but you may have character pointers as the input to functions, and those character pointers mean the same things to C at least, and to those functions. So the pointer and the array are both the address of the start of the data, and the end of the data is wherever it sees this null terminator. So if we give a character pointer to a function, what we can often say is that I'm giving you the start of the string, you can keep going until you find the end of the string. So we're not actually giving a memory limitation when we give a character pointer like that. So every time we were giving something to printf and things like that, there was actually one of these on the end because we were using the double quotes, and double quotes was going to create that null terminator automatically. And so when we create either of these, we would end up with an array that had 6 elements. So we've got 5 letters here, and then the 6th one in there is the null terminator. There are different functions that we can use. Oh, there's a lot of talk in there. Oh, are we having an argument between programming languages now? I think we're like, we're early at the moment. So I think for a lot of people, C will be your first programming language, but hopefully it won't be your last. Those of us, it's just the longer you code, the more you accumulate these. I think after a few years, a lot of us have got like a dozen different programming languages that we've seen, and we'd be reasonably confident of being able to use given enough time. But whether you're fluent in something or not, it's a different matter. But anyway, the beauty of programming languages is that they are based on a logical foundation. So being based on a logical foundation means that the stuff that goes on top of the programming language is just flavor. I think rather than trying to count how many programming languages is thinking about how deeply you could know any of them because of the fundamental knowledge you have of programming itself. often think that's a better way to look at it, especially because, I mean, people get into these big arguments about which programming language is better, and that just doesn't make any sense because every programming, well, some programming languages are old and outdated. That happens. They get superseded by something that does the same thing as them better. But a lot of the time, when we compare against currently used programming languages, we need to compare them based on what we're trying to do with the language at that point in time. So if I'm trying to do low-level optimization of running, then I won't use Python, even though Python's a very easy language to write, but I would use one of the C-based languages, like C or C++, because I know I can do direct memory management in those, and that's going to be faster. If I'm going to use a language that is very specific for teaching people certain things, then, sometimes I would use one of the simpler languages to get into. So one of the ones that doesn't have all these fiddly bits that C has, like Python's a good example there. Sometimes JavaScript, but JavaScript's really, really web-based. So unless it was going on a web page, I wouldn't use it that much, right? So you see how I will just fire off all these different names of programming languages and say, yes, they're all good for their purpose. So saying that one language is better than another is a weird thing, because that is implying that the context for how you're using the language isn't going to change. So anyway, it's just always interesting because people get into arguments about which programming language is better, and it's not an argument because it depends on the circumstance you're trying to use it for. Like, one could say that assembler is the best programming language because it gives you complete control over your computer. And then you say, we have to deliver a front-end web page within 24 hours. Would you like to write it in assembler, or would you like to write it in one of the JavaScript packages? And then everyone's like, there's React over here that we can use. Or I have no idea how to make a web page in assembler. I don't even know if that works or not. And so you get this kind of difference where, like, fit for purpose is more important than objective quality of the language. Anyway, you have all triggered me into talking about something that's not on my slides and things, because I just don't like the argument about different languages, because I think that they're all useful for a particular purpose. Except, thank you, Alex, for Visual Basic. Visual Basic is no longer useful for much. I used to program with Lego Mindstorms. That was fun. Scratch is really good for teaching. If you want to teach people without bamboozling them, Scratch is amazing. So it's got a really good purpose, right? You're all going to be quiet now, and I'm going to lecture. This is so funny, because I very rarely will tell my class to be quiet and listen while I talk, but now's going to be one of those times. We're going to stop triggering Mark by talking about different programming languages, and I'm going to go back to lecturing. Okay, so when we're reading and writing strings, I'm just going to, you know what I'm going to do? I'm going to cover up that chat window for a few minutes so I can't see it and it can't throw me off. We're going to lecture. We're going to properly lecture. Okay, so if we want to read an entire string at a time, so remember how we were looking at the idea that we couldn't scanf into an array, but it might be nice to have something like a standard library function that would do that for us. So fgets will actually do that for us for strings. So what we can do with fgets is we put in the array. So we've already made the string object, which is the character array, and we put in the maximum length that array could be, and then we say where it's coming from. So for the moment, you don't have to worry about the stream. If we were doing things like reading some stuff from files, reading some stuff from network connections, and reading some stuff from the terminal, we would have fgets from different streams. But for the moment, we're only reading from the terminal, which is the standard input. So this will always, in your programs here, be standard in for the moment. Later on, when you go through other courses, you might try other things with it. We'll create a character array to put in there, and we'll also have a maximum length. This will be the maximum capacity of the array, or if you want to, it can be the maximum length of content that you're going to read in. So when we type our stuff in the terminal and we press enter, everything that we typed in will be read in by fgets there. So all the characters on the line that I typed in will be put into that array, so long as they are not longer than the length there. We do not have to type in the null terminator it's actually impossible to type in the null terminator. There's no character on the keyboard that is the null terminator. So what fgets will do is it'll take whatever you typed in and then add the null terminator to the end. Which means when you think about it here, the length, you will only ever have length -1 characters in that array, because the last character, wherever that is, but if it is at the very end at least, is reserved. There's one reserved space to make sure a null terminator will fit in that array that you've asked it to put it in. All right. I'm opening chat back up now, but I'm still not going to read it. Okay, we can also read and write lines of code. So there's another one called fputs, which allows you to print out an array to standard output. So this will just dump an entire array of characters to your standard output. So these are nearly like kind of shorthand things to deal with entire lines of text. So where scanf might want to grab individual words at a time separated by spaces and things like that, fgets and fputs say, I do not treat spaces or other characters as different from my input. They're all going to go in together, and so we can just put them all into the array together. So fgets and fputs might be things that you want to use. I would say that when you want to focus on these things, I would focus on getchar and fgets, the input ones, because the output ones like fputs and putchar, you can quite easily use printf instead of those. Whereas fgets and getchar do have specific purposes that scanf can't necessarily handle. I mean, it can, but it's fiddly. So I would say if you're only looking at some of this stuff to learn about, it's the input ones, fgets and getchar, that are useful. The string library also has a whole bunch of useful functions. So in the same way that we had ctype.h, we have string.h, and string.h has a whole bunch of little functions that we can use. And I was saying before that a character array here, the array is the address of the start of the memory that the information is in, which means that you will often see pointer s saying, here is the start of the string, and read through until you hit a null terminator. So we've got things like this thing can count the length of a string. You could write this yourself pretty easily, where you just do a while loop through a string, and when you hit the null terminator, you say, this string is now over. This is how long this string was. And we can also have some nice things that copy strings into each other, attach strings to each other, compare two strings, and all this kind of stuff. So there's lots and lots of different different little things for strings that could make your life a lot easier whenever you're using them. I think Tom and Trey have been coming in and are good. We're not talking about programming languages anymore, but I think we're talking about things like null terminators and stuff like that, which is good. Rosie's asking if the final exam in this course will be more application-based, writing code and submitting, just like the weekly coding tests and labs. Yes, there will be a significant amount of that in the exam. You can think of it like this: we're going to examine you in the same way that we have been the whole time. So we've been assessing you in ways with assignments, weekly tests, labs, and stuff like that. We're not going to create a new format that you're not familiar with in the exam. So we want the exam to ask you things in a way that you're familiar with, but questions that you haven't answered before, to test your ability more than your memory, which is why it's new questions, not old questions. It's not going to kind of flip the script on you in any way. So you're going to be able to be comfortable in the exam environment. You may not be comfortable with the difficulty of the questions, but that's part of assessment. But you'll be comfortable in the environment. We're not going to ambush you with a weird environment where you need to do things. Okay. Another thing that I was going to look at today to show you is command line arguments. So sometimes we may want to run a program that actually gets information as it runs. So for example, here I've got this thing, /program. So you can see this term that you would have seen before. So after you compile something, you then run it. And when we run it like this, we can actually type more stuff. And if we type more stuff here, these things become what we call arguments. And arguments is another word for inputs or another word for parameters. Like there's lots of different words for the things that go into a function. These become the things that go into the main function, and they're called command line arguments because they're arguments that are written on the line that has the command that runs the program. So the command line is the line of the terminal where you're typing stuff in. And so that's why these things are called command line arguments. So these things are going to get passed into our program and we're going to have access to them. Oh, I need to move my face out of the way for a moment so you can see my awesome meme here. So I think this is like one of my, I was just like about this meme because it's a meme about arguments and it's an argument about arguments. Anyway, okay, I'm going to cover it back up again and go back to talking about programming. So int main is not always going to be void. It can have this specific format. So it's not just any format, it's this specific format. So in this specific format, it has an integer called argc, and then it has this full-on thing here, which we have not necessarily seen before in this format, but I'm just going to explain what it is. So, character pointer, array. So this is an array of character pointers. If it is an array of character pointers, that means it is an array of strings, because as we saw previously leading up to this, that anytime we saw a character pointer, we could potentially use that as a string. So sometimes it's a pointer to an individual character, but a lot of the time it's a thing saying, here's where the word starts, and you can read through until you see the null terminator. So what we're getting here in our arguments, in our inputs to our main, is argc is known as the argument count. This is the number of words that were typed in on the command line when the program was run. So for example, here, 1 word, 2 words, 3 words, 4, 5, 6 words. So argc would be 6 for this. Note that I counted the name of the program. The name of the program actually goes into the main. So the main, when it runs its with its argc argv, the first element in the first string in that array will actually be /program. It will always have that. And then in this array will be stored these actual things. So one string that's this, the second string will be this, third string will be this, fourth, fifth, sixth. Like what scanf did previously, it will ignore spaces. So it's not like a getchar thing. It's saying that the spaces are not information, and anything with letters or numbers, for example, here is information. So that's how our things will be stored, and then our main starts to look like other functions that we've done before that have input. So if it has input, then this integer argc will be usable inside the main, and this array of strings will also be usable inside the main, which means we can just grab information from inside the main. So I have an example here, which is in the lecture slides, which is the arguments demo. And the arguments demo, what it does is it just has an internet argument with you every time that you type something in. So you type anything in the command line, and what it'll do is says, well, actually, I think there's no such thing as, and whatever you typed in. So it's just an internet troll. So what this is going to do, let's look at how this works. Argc argv will be created when the program starts based on what you typed in on the command line. So if you type nothing in on the command line, then there will still be one word that comes in here. So I mean, typing nothing in on the command line makes nothing happen. But I mean, you typed in the name of the program and nothing else, then there will still be the name of the program here in this array. So you can't actually have this thing run without at least one word going into this array. So what we're doing here is we're saying the name of the program is the first string that gets printed out in this printf. So I don't think I've shown you the %s yet. I should have put a note about there. %s will say I can take an array of characters and print them all out together here. So, well, actually, this program name says there's no such thing as, and then it's looping through from I equals 1 up until just before argc. So this is looping through an array, because if this is the number of arguments, it's the length of this array of words. So remember that we can think about it this way: character pointer, an array. This is an array of character pointers. So what I'm doing is I'm going through that array and taking one word at a time, and then I'm doing an fputs on that word to my standard output, which is this is the stream. We don't have to worry too much about what the streams are, but this is the output that goes to the terminal, and in between each of those I'm doing a printf. I have a demo of that. Let me see if I've downloaded it already. Oh. That's awkward. Tom or Shrey, can you do a little back-end checking here to see whether VLab is down at the moment, or whether this is my problem? I'll keep talking about other things in the meantime. Okay, I will show you that demo if if VLab is running. If VLab isn't running, then I'll figure something else out. I don't actually have... Oh. I wonder if that was my computer, because it was just really, really slow to load up the slides as well. It's weird because I'm still streaming. If I'm still streaming, it means my network is running. But I'm having these weird issues with my slides and well. Okay. Tom's suggesting let's try going for one of the specific VLab servers. I think this might be a my computer problem, because it's just sort of stopped for the moment. While I've still got my slides and they're still working. Ooh, unable to resolve. Okay. I'm going to deal with that in the break instead of trying to deal with it now. So I'm just going to talk a little bit more about command line arguments without actually showing you a demo just yet. Okay, but anyway, we have a decent idea of what's going on here. This is an array of strings, and we're going through the array of strings and outputting them one at a time to the terminal. Interestingly, argv is defined as an array of character pointers, which means it will always be sets of characters. I mean, the set can have a single character, but always sets of characters inside argv. But sometimes when we type something in on the command line, we're actually intending for it to be numbers. So for example here, I can say extra information 1, 2, 3. So 1, 2, 3 are going to be read as the characters 1, 2, 3 and not as the numbers 1, 2, and 3. So if I wanted to convert characters into numbers, so if I had the characters for, I don't know, 986 or something, and I was to read that, it would say, okay, that's a string with these ASCII values in it. Those ASCII values have no relation to the numbers themselves. So how do we then try to read that as a number? I have a library function here that's part of the standard library that will convert strings to integers. I'm going to point out here that there's about, I can't remember, there's about 8 of these different functions in the standard library that all do the same thing, that do some form of converting string pieces to integers. So I'm showing you one here, and this will be one that will be reasonable for you to use in this course. So it's called str2l, which is short for string to long integer. We're not actually using long integers at the moment, but this one works quite well for what we're doing. So it converts the string, which is any number of digits that it finds, into whatever number that represents. So this is converting from a string that represents a number into an integer that actually stores the value of that number. So what we can do is, if we have command line arguments that are just numbers, and we're trying to make them into numbers, so here we have looping from 1 onwards, and if you remember what I was saying about the argc and argv, the first argument that goes in is always the name of the program. So if the first one, element 0 is the name of the program, and we're trying to read in the numbers that were written afterwards, we start at 1 rather than at 0. So we're starting from the second element, and we're saying use string to long to convert the argument that is in this array of strings into a base 10 number. Don't worry about the thing in the middle. The thing in the middle is a pointer that we're not using. There's extra capacity that string to long has that we're not using, so we're going to use that as null all the time. But we're saying read it as a base 10 number. And remember that we have different numbering systems that we could use. So if it was a pointer address that I was trying to convert, then this would be 16, because pointer addresses are usually in hexadecimal. If it was a binary number made up only of 1s and 0s, then this would be a 2. But most of the time, if we're taking human input, humans, we're mostly going to type in numbers in a base 10 system. So you can nearly use this and ignore the 2 extra inputs here and say this is always going to be null, this is always going to be 10, and this is the number that came in as a string that is going to get converted into an integer. So this thing converts it into an integer that can be added to this total. So this is just adding up the total of the command line arguments like that. Someone's saying, why do you need to read these? Well, it depends. I mean, one could consider that every program we ever write, we could say, never put anything on the command line, and we will always type in our input from the beginning. But sometimes programs like to have stuff at the command line so that they can decide when they start running what kind of mode they're running in. So you can have, say, I run my program and then I put a line afterwards saying what it's going to do. A good example of that is something like DCC. So the compiler that you've been using a lot in this subject, you can say DCC, and then you say the file name. So if DCC was a C program, which I don't think it is, but you would run it using DCC, and then you type in your file name. So what it would do is it would say, okay, I got more inputs than just the word DCC. I'm going to look through those inputs and see which of those are .c files. If I have .c files in that, so we would loop through this array of strings looking for anything that ended in .c and say, okay, I found these things that ended in .c, or usually there's only one file that ends in .c, and we say, okay, this is the thing that we're going to translate into something else. If I read through and I see -o, like we've been using to name our output file, I would say, okay, so the -o is here, which means the next word that came in on my command line input is going to be the name of the file that I write to. So we could do all those kinds of things so that you can just run your command like that with the bits afterwards, and it will just use them to run the program. Oh, Miguel was saying about DCC as well. Yes, DCC is something that uses literally those command line arguments. Okay, so we're gonna take 5 minutes break, and I'm gonna try to figure out why I can or can't connect to VLab. Hopefully I don't have to restart my computer, because if I have to restart my computer, that means I may have to shut down the stream and start it up again. I haven't actually tried doing that in the past, so we'll see how we go with that. But I wanted to just talk about like being halfway through COMP1511. So in terms of time, we are now halfway through COMP1511. And I know the halfway point of every subject. Yeah, thanks Tom, we can always just use the gateway. The halfway point of every subject can be really tough times, because you know that you've got some stuff, you know there's stuff you don't 100% understand, and you know there's a ways to go yet. Especially this kind of late October part of the year is usually when everyone's energy is like at a pretty low point, and you're just like, oh, I just need like, we've only got 2 months left, like I just need to get to the end of the year, and I just want to say I understand, because I feel the same way. You know, 2020 has now been going for roughly 2 decades. It's been, for most of us, the longest year of our lives, and the most we've had to deal with. So we're all tired. It's just going to be a part of for what it is. And so when we are tired like this, a piece of advice I always have is to not think about achieving your end goals, because your end goals are really, really far away. What's more important than whether or not you think you can achieve this goal of being an amazing programmer or completing your degree or anything like that. I mean, some of you might be close to completing your degree, but it's different for everyone. But when your goals are that far away, remember that every step you take towards your goal is worth it, and it's still going to help you get there eventually. And it's not important if it looks like you're not going to get there for a long time, because that's like future use problem. But for the moment, make sure you make future use job a little easier by at least knowing that you can make little steps along the way. So I just want to say that because I think it's pretty handy to think about that when we're halfway through a course. So we'll go on break now. It's 12:05. We'll come back at 12:10, and I'll show you the demo that we're going to do today. Hopefully I will show you the demo. I will make sure that I can actually connect to the coding system that looks the same as the one that you're using. Okay, I'll be back. I'm back. And I got VLab working as well. Through the magic of figuring out what was wrong with my internet connection without having to turn it off and on again. See, that's a high-level computer scientist. I didn't immediately just turn everything off and on again, and I still got it working. You too can reach these dizzying heights of technical capability if you study hard enough. I just turned something else off that I realized was eating up all my upstream data. I don't know, understand why, because my stream, as in the thing that's throwing thousands of kilobytes a second up to the internet for you to watch, was fine and not being affected, but something else was going on. Yeah, very, very weird. Anyway, let's move on. Okay, so what are we doing now? I have a demo here, which is called the Rhyming Helper. And I'm going to say, whoa, we're halfway there, which is like we're halfway through COMP1511. If anyone doesn't know what I sang there, this is the chorus from a song by a band called Bon Jovi called Living on a Prayer. I think it might be called Livin' with an apostrophe on a prayer because they're cool in the 80s. It's a sad point at the moment that this doesn't exist for a lot of people right now, that going to a bar and singing karaoke here in Sydney, this song will come up. It is like, it's just like this thing that's embedded in in drunken singing in Australia, that this song will turn up at some point. But I apologize to anyone who is overseas at the moment who didn't necessarily this term get the chance to come here to Australia and maybe experience this thing firsthand. I mean, it's half an apology and half a like, hey, you got away with not experiencing this thing firsthand. But it's also something I always like to think about when we're halfway through something, is I end up singing this song. Yes, and Kat saying The Land Down Under as well. So there's a lot of like fun things like that I feel at the moment I'm missing from the student experience. So obviously I have to bring them into the lectures instead. Okay. So the program that we're running is a rhyming helper. So it's going to do a couple of things. One, it's going to read in a string from the command line. So we're going to say that the string in the command line... Paco's saying that we're not expecting international students to get back to Australia until the end of 2021. That's a long time, but I mean, I guess it might be something like... I don't want to go too deep into it because I'm not an epidemiologist, but I assume sometime around a vaccine appearing that we might actually see people being able to come back. Anyway, instead, I will now sing the entirety of Living... No, I won't. I will not sing the entirety of Living on a Prayer for you to give you that experience, because we have actual lecture stuff that we're going to do. So, what we're going to do is read a string from the command line, and then we're going to read a string in the program, and we're going to say the command line is like a line of a song, and then the string from the user is a word, and we're going to check this word against the last word of the line of the song and say, do these rhyme? Now, we're not even going to check very well whether they rhyme. We're just going to see how similar those two words are, and then we're going to give back some kind of rating of similarity. And so at this point, in COMP1511, we've taught you all this stuff like if statements, while loops, arrays, pointers. I don't think we're necessarily using pointers that much in this, but all these kinds of things, and now characters and strings. This program will use everything. So it's going to use everything that we've used up until this point, in bits and pieces. So where are we going to start? Let's start with a simple version that reads a string in from the command line, and then let's start off with just one character. So let's just say one character from standard input and say, is this in the string or not? And then after that, we'll go, okay, rather than just one character, let's do a whole line from standard input and see whether that's... see how well that line matches the last thing in the command line. So I have here, nice and working. I actually just created this over the last 2 days, so I have it still here as a solution, but I don't want to look at the solution because I want to actually build it up with you. So Oh, I've also got the arguments. I'm going to let you play around with that yourself. I don't want to jump back to that now. So I'm going to make a new file called rhymer.c. A program to determine if a word rhymes with a line of a song, reads a line on the command line, compares the input string against the last word of the command line, makes a guess at how well they rhyme. I'm going to say makes a guess because I have actually specifically done this so that the code is not too excessive, because if we really wanted to know if things rhyme, it's super complicated. So instead I just went, okay, how many letters are the same? It's like something simple like that. Oops. Comment there. This is written by me. And we're still in October. Okay, so int main. Ooh, if I'm going to read stuff from the command line, I'm probably going to need to include my input-output library. There might be other libraries that I'm going to use here, but for the moment, I'm assuming that this library is the one we're going to use for now, but we're probably going to use more, so I will add more libraries in there. But I'm going to add them in as I need them, once I figure out that I need them. So my main is going to take stuff from the command line. If it's going to take stuff from the command line, it needs to have that exact argc, argv layout so that it knows where to put the things that it wants. So this is the kind of thing that you can see I've got it memorized because I've had to type it in so many times. You will eventually, if you keep doing stuff like this in C, have this memorized. If not, you can always just copy and paste it from the slides, because this, when we're working with command line arguments, this will never change. It's always going to be this layout. So if I want to read stuff from the command line, I need to make sure that stuff from the command line works. Oh, someone asked, why is something purple? Which bit? Shrey said, during the final exam, I will record myself singing so you can watch it when you're finished. I did threaten in one of the previous online exams to just live stream through the whole exam and talk to people and not answer any questions. I think that would help less than if I'm not there. Okay, no, there's nothing else I need to necessarily read there in chat. Okay, so if I want to check whether someone has actually given me a rhyming line or not, I've got some code here as well. So I can say, if the arguments, if there aren't enough arguments, then I can say we can't rhyme that. So I'm going to do a check here that says if argc is 1, but I'm going to be extra safe here just in case something goes wrong with the program. This is very unlikely to happen. But I'm going to say if it's less than or equal to 1, it means that the only thing that I received was the name of the program. So no extra arguments. Oops. Are on the command line. So if I've got no extra arguments, then I don't have anything to rhyme with. So I can say there was nothing to rhyme with. And I'm going to say, well, there's no way out of this. So I'm going to return 1. I'm going to say that this program did not finish the way that I expected it to, so I'm going to return 1. Otherwise, I'm going to return 0 here. So that's my way of saying, if you didn't give me something to rhyme with, then there's no point running this program. because I need at least one argument there to rhyme with. And this is nearly like I've put an else here and put the rest of my program, because if we're inside this if, we're going to finish. So we're not going to do anything. So I could put an else here, but I don't need to, because I know that if the if runs, the whole program ends. Otherwise, we continue. So if I know that I have something on the command line, I could nearly say that at this point, we assume that there's something in argv. There's always something in the first element of argv, but this is argv1 and possibly more. So we know there's at least one thing that we can assume is happening there. Okay. If we know it's there, it means we know we can use it. And if I'm saying I want to rhyme with the final element in argv, then I kind of know that the final element of argv will always be argv argc minus 1. So I'm just putting this stuff in comments here because it's stuff that I'm going to remember as I'm using it. Because this is the array. This thing always tells me how many things are in this array. So this is the size of the array. The size is not an index. The size is always just one bigger than the indexes. So if I could do argc minus 1, so the number of items minus 1 will always be the final index in any array. So if I've got an integer telling me how big an array is, and I have the array, then I can always kind of do this. Size minus 1 will get me the last element. So I'm just leaving that comment in there for myself to remember. The word I'm rhyming against is this one. And we'll get to that later. So the other thing we need to do is take input from the user. Single character. So I just wanted to do single character so that I could test a few things first. The code that I'm writing for the single character will probably be removed entirely. There's two options. One, we can take the code we write for a single character and we can loop it so that we can read multiple characters, or we can replace it. So I may end up saying you could loop it if you want to, but I'll replace it with something like an fgets, I think, because I know that can take an entire line of text as input. So if we're going to take input a single character, I need something to store that character. I'll call it input char for the moment. I might. Now recall, some of these things that I was doing with input is I initialize something even though I'm about to write over it immediately. But I can initialize it as something that I know is going to trigger an issue. And so I say that if I say that input character starts off as the end of file symbol, it means that this can't possibly be read in as something random. So if my get char fails to write a value into input character, then I know it's always going to be end of file, and I'm going to be able to say, don't try to do anything with end of file. So then I can do get char. Get char is a function, and if you do need to look up information on these, it's something as simple as I just typed get char into Google, and I'm just like, okay, first thing, oh, you can see it's purple. I've been here because I was actually rehearsing what I was going to do. Okay, so get char here says int get char void. So get char does not have any input, so I don't need to put any input, but it is going to return an integer. Gets a character, an unsigned char from standard in. This is equivalent to getC blah blah blah. I don't know what getC is, so I'm not going to look at that. So this is the way that I will often look at the library. I will say, okay, there's these other functions they reference, but I may not need to know about those. The return value returns the character read as an unsigned char, cast to an int, or end of file on end of file or error. Okay, so this is a whole bunch of extra information that I don't necessarily need to know, but I know that it's going to read the character. So I know that I can use that, and its output is going to be the character. So I'm going to say input char is equal to get char. So this is saying I will take a single character from my user input. I might want to tell my user that I'm doing that. Otherwise, this thing's going to run. It's just going to have a cursor just sitting there. So it's probably better to say something like, please enter a character. I'll put a colon there so they can write the character on the same line as the printf. Okay, so that we get the character, and once we've gotten the character, we then want to, I'm going to to-do for myself in here. Check, well, actually I don't even need a to-do. We're going to do it immediately. So check whether the character is in the final word of the, we need another line. Command line arguments. Just make sure everything's happening on the stream. At least I've got Shrey and Tom, I think, are in there answering questions if people need. Yeah, Shrey's boiling down an array into the fact that an array, the name of an array is just the address of where the array starts. So a character pointer can nearly be thought of as an array of characters. It's not exactly the same, but functionally, as long as you're using it in the right way, it is the same. Okay, so we're going to check whether a character is in the final word of command line arguments. I'm going to show you something that I do sometimes. Let's just call it result for the moment. I'm probably going to rename this variable. Check character input char, and what is the string that I'm using? I'm glad I put that in comments. That's the string that I'm using there. Oops. Okay. Can you see what I have done here? I have called a function that doesn't exist. Because what I'm doing is I'm thinking about the fact that this check for whether a character is in a string or not is something that I think I want to put into separate functionality. Because I'm already thinking about the future where I might want to do this check multiple times. So I'm like, okay, I know that it's going to have a result. The most basic way I could report a result is an integer. I haven't thought about exactly what that's going to be. But what I'm going to do is I'm going to say, okay, I'm going to write this function, and it's going to get a letter, and it's going to get a string, and it's going to tell me if this letter appears in this string. It might even give me better information than that. Like I could probably do which index is this character appearing in the string, and that kind of thing as well. So now that I've got this, I'm going to say I need to create this as a function, because if I'm going to use it as a function, it needs to exist as a function. So check char is a function that gives back an integer, so it needs to be an integer type function. The first thing it took in was a single character. The single character I could potentially do as a character. I'm on the fence whether this should be a character or an integer. I think I may want to follow the blanket rule that I said, and just like individual characters, we're always going to use integers. Just in case something slips through here and this gets given EOF. Because it could, potentially, because input char is EOF there. So maybe I should think about that as an integer just in case the character doesn't fit. And this is going to be a string, which is going to be a character array. It's going to be I'll call it word here because I think it's word. So I could do it like this, saying it's an array. I could also do it like this. Both of those, when we're working with strings, functionally are going to end up being the same thing. So I might do it this way. I think I've already, which is really funny because I wrote the slides for this last night. I think I've already broken off from what I did on the slides. I'm not 100% sure if I'm okay with the EOF here if this fails making it to here. Because I think if the user types in something that's not a character, I don't really want to let that through that far. So I might actually check this here. So if the input character is EOF, that means that it was set as EOF from the beginning, and then we tried to override it with a get char. So if the get char didn't run for whatever reason, and it remained as EOF, then I know there's a problem. If the get char did run, but it couldn't read a valid character, then it was going to write EOF. So if input char is still EOF at this point after get char has tried to run, it means that something went wrong. I'm being very, very verbose with my comments here, mostly because this is teaching. When you're writing code yourself, you probably don't need quite this much. All right, so if this is EOF, then there's a problem. So I'm going to do something like, I'm going to say, couldn't read a character. And then we're going to return, and we're going to say, there's an issue here. So check out what I'm doing with my return values, right? So return 1 was there was no command line argument. Return 2 is I couldn't read a character. So actually starting to use error codes here. Having said that, we're not even going to see those error codes when we run our program, so it's not necessarily that big a deal. But I'm doing it out of instinct, so that anytime there's an error, we can do different things. Okay, so at this point, I know that my input character is not going to be EOF, because if it was EOF, then we would have ended the program at this point. So I'm expecting this to be a correct character variable, which means if I want to, I could potentially put that as a character input. I'm going to argue about that because I think maybe I'm going to keep it as an integer just in case. Okay, so check char, check character. Is it check car? Or, I don't know. It's like pronunciation of abbreviations. I'm rhyming again. So this function is going to get called, which means if it's going to get called, it's going to need to exist. So let's take this and put it down here and say checks if input character is in word. So I'm saying this is a collection of characters. This is my input character. Is that in that? But I also need to decide what my return value is. Returns, you know what I'm going to do? What I'm going to do, returns the index that it finds input char at. Or returns something that can't be an index. So if it can't be an index, I'll go for a negative number. It returns -1 if it can't find input char. Okay, so this is a decent situation. I know that my output is either going to be where I found it in the word or -1 if I didn't find it in the word. So now what I'm going to do is pretty simple, right? I'm going to loop through this word, and if I find the letter in the word, then I'm going to set my I don't know, found location or whatever variable it's going to be, my integer, to whatever the index was when I found the letter. Otherwise, I'm going to say it's -1. So what will I call this variable? Found letter. I'm just looking at my yeah, I'm using snake case today. I don't know if everyone's noticed. I've just switched between things because it's useful to know how to do either one depending on what other people are working with around you. So I'm going out of my comfort zone today and doing snake case because I instinctively do camel case. I don't know why. I think it's because I spent a few years as a C++ developer doing that, so it ended up like that. Okay, so I'm going to say found letter is -1, and I'm going to return found letter. This is my safety net. So if nothing else happens, I'm going to pretend I didn't find it. However, I do need to put the effort in to actually find it. So in order to look for it, I'm going to want to loop through the list, and I'm going to list the word. I'm going to do this as a basic loop. So int I equals 0 while I is less than the length of the word. Oh, I don't know the length of the word. How do I know how far am I going to loop? A few moments later. I need to decide when to stop looping. So there's an option that I do this for the length of the word, and there is a way of doing this, right? because I showed you a function earlier that said I can do sturlen, which is strength. Strength. I'm just like, what am I doing? I'm talking role-playing games now. Wait, where am I? I could use that string function. Where was it? Here, I had a string function that would tell me the length of a string. Okay, that's one way I could do it, but there is another way. And yes, Miguel has picked up on it there as well, is like, what about we loop up until we hit the null terminator? Because I've been saying this whole lecture, it's like the null terminator marks the end of the word. So I don't need to know how long it is. I just need to know I'm going to keep looping until I hit the null terminator. So let's say if I am looking for the null terminator, what I would say is while word I, so I'm looking in the word and saying, okay, at this letter in the word, if it becomes the null terminator, then I want to stop. So while I'm getting normal letters and not the null terminator character, I will keep looping. Now, we are hinging this on a certain level of trust. So what we're saying is, you did not give me a null pointer here. You did not give me an empty string. What I'm saying is that if you gave me a string to go into this function, I'm assuming one minimal capability. I'm assuming that whenever we pass strings around, there are never zero length strings. There's always, if you're saying that the string is empty and has no information in it, then I expect the first character in the string to be a null terminator. But what I'm assuming is that this will always have at least one letter in it. So I equals 0. If I test it the first time and I get a null terminator, then at least I got a string. I have assumed that this word has some letters. So you've got to be careful with that, because all the work we're doing on strings hinges on this null terminator existing. And it is, of course, possible to create an array of characters that doesn't have a null terminator in it. You should try it sometime. Make an array of characters that doesn't have a null terminator and start running string functions on it, and you see what happens. They go off the end. So in the same way that if we start looping and we don't stop looping at the end of the array, we start trying to access memory outside of the array, our program's going to say, no, you can't do that. We have to stop here, right? So at the moment, we're making that assumption. We're going to work with that assumption. So this will allow me to loop through the word. And if I do my I++, that means I will move through the indexes, looking at it a character at a time. So for each character, we're going to do a test. So if word I, which is the current letter that we're looking at, is the same as the input character, we've found a match. Probably didn't need that comment. You can kind of tell that we found a match here. If we have found a match, then found letter gets set to the index. And we're going to keep going through the list. We may find multiple matches. If I run it like this, what we're going to get is the last time that we find a match is going to be the index. So if we find multiple matches, found letter is going to get replaced multiple times, but that's okay. So I could actually say here, returns the index that it finds the input character at. It's actually more specific than that. It's returning the last index that it finds the input character at, which is okay. I'm okay with that. I'll tell you more about this later. So if I find it multiple times, I'm looking for the last time I found it. And then if I have found it, I will say found letter. I will always return found letter, whether or not it stays at -1 or it gets replaced by something, I will return it. So this is my way of saying, if I don't find it, then I've already got my -1 there. If I do find it, the found letter variable gets replaced by the index. Dan's like, don't forget the I++. Yeah. Raymond's saying, if you know that at the end of the string is the null terminator, can you change it? Yes. If you want to change the length of the string, you can overwrite the null terminator. So if you know where the null terminator is, you don't even need to know where it is, because I've just shown you a loop that takes you up until where the null terminator is. You can say, I want to add the letter X to the end of my string. I can then take this word I, once we've looped through to there, and then just change it to another letter, so long as I make sure that there is a null terminator at the end of whatever string that I've ended up creating. Lots of little issues there, like is your array big enough to hold this and other stuff like that. So we haven't even thought about how big our arrays are. So we've got no hash defined for our maximum size or anything weird like that here. So at the moment, we're assuming that the arrays here were created by the program as it started, and they're exactly the right length for what they're going to do. The only other thing that we've created is an input character there, and we've got our check here. At this point, we kind of want to do some testing, make sure this is working. So I've got my result. So I can do something like this. Printf found the letter, and we'll print out the character at index, and we'll print the number, and the letter is input char, and the number is result. I don't like result. I don't like that. I'm going to rename that variable. I nearly want to use the same found letter. I guess I could, because what goes on inside curly braces stays inside curly braces. So this found letter, because it only exists within these curly braces, won't interact with another variable that I have the same name as here. So I could call it the same thing. So found letter checks whether it found it or not. Oh, you know what? I'm going to call it found char, because then it lines up with input char. It's like, it sounds similar. That's only gonna make sense if we do find it. So I might just do an if. If found character is, so it was going to be -1. Right. If it's greater than or equal to 0, then I say we found it. I'm going to Control X and Control V, cut and paste that. Otherwise, we're going to say something different. Did not find character. Okay, so we've done enough stuff now that we probably want to test it. Oh, Jamie. Can you get around array length problems with linked lists? Yes, you can. And we will be spending a good 4 weeks on linked lists. We'll get there. We'll get there. Okay, so this is enough to test whether our check character function is working and whether our input testing is working and stuff like that. This is actually a lot of code to write before we started testing, but we weren't really at a position to get output yet until that point. So let us find out all of the typos that I have in my code now. Well, there you go. The danger of it going right the first time. Okay, so we need a line of a song that we're gonna rhyme with. What's his name? Is it Tommy or Johnny? I can't remember his name, because like you just kind of sing either one and you'll get away with it. By the way, the line that I'm typing in here is the first line of the song that I was talking about, Living on a Prayer. Please enter a character. So I know that my last word there is going to be docs. So I could say character C. Where do we find the character C? Found the letter C at index 2, 0, 1, 2. Okay. It is Johnny. Someone said it is Johnny. I don't know why I keep thinking it's Tommy. Tommy's another song from that era. It's probably Bruce Springsteen's song or something like that. Okay, let's test that again and say, what about the character X? Is the character X in there? Did not find character. Okay, my initial testing is sort of working here. My initial testing is saying that I can or can't find the letter in that character. So the letter in that word. Okay, so we can read in a single character, and we've got a function to find a character in a string. This is very similar to what I just wrote there. And I've talked about that already, the last word. So let's try testing a whole word. So there's a couple of options we could do for a whole word. So one of them is this single character input. Raman's asking, how was it indexed to? So check what I put into checkchar here. I put a single word into checkchar. The word I put into checkchar here was the final word. So the only thing it's checking is this final word here called docs. So C in docs is at index 2 of this word. So index 0 is D, index 1 is O, and index 2 is C. So that's why it's saying I found the letter C at index 2. If we want more information from these things, we could actually get checkchar to tell us what word it's checking against and stuff like that. But we'll do that once we need to do some kind of maybe debugging and stuff. And Josh is like swearing that that it's Tommy, not John. Yeah, that's why I couldn't remember either. Maybe it's because I've never tried to sing that song and take it seriously. It's like we're all gonna forget like certain things, but none of us are gonna forget the chorus. Oh, so people are saying it's Tommy. Oh yeah. Consensus is saying that the character in the song's name is Tommy. Okay. Anyway, we've got to this point, so let's think about now taking in more than a single character, but taking a word as input instead. So one option is I could loop this multiple times, and as I loop it, I could insert these characters into an array. I'm going to do an easier version than that. So what I'm going to do is comment out that, which is going to take a single, actually, I think I'm commenting out the whole lot, because this was all based on a single character. So what I'm going to do is I'm going to say, okay, that was if we had a single character, but if we want a line of characters, we can instead ask our user for more input, take in a string as input. Oops. Thank you, autocomplete. Type in a word to rhyme. And then we will use fgets. So fgets is going to read everything that gets typed in, and then store it all in a string, which means that fgets is going to need a string. So it's going to be a character array, and I'm going to call it same kind of naming format that I was using. I'm going to call it input line. And now I can't just say this is exactly the right length, because it can't be the exactly right length, because we don't know how much our user has input yet. So we're going to need some kind of maximum length. Hash defines to the rescue. Max length. Let's just say we're not expecting words to be too long. So I'm going to say, just to be on the safe side, if you want to rhyme with a 100-letter word, then good luck to you. And I think the German rap scene will highly appreciate you, because I think German's one of the few languages where you could literally get a 100-character word and try to rhyme it with something. I actually have no idea what the German rap scene is like. I don't think I've ever heard any German rap. Okay, so max length. Did I spell that correctly? Because I was trying to autocomplete. Yes. Okay, so I've got max length there. So this is the maximum possible length of the first word. We're not first word, the word that gets typed in. We're not expecting it to necessarily get to that length, but you know, we're going to use it as that anyway. So fgets. I need to remember what order things went into fgets, and I don't remember. So I wonder if I can just type it in this search. That's weird. That just went out of that site, even though it looked like the search bar for this site. Okay, fgets takes in character pointer, string, the maximum length, and the stream that it reads from. Okay, so first thing that went in was the array, input line, then the maximum length it could be. Luckily, I've got that written down as maximum length. Where it comes from standard input, which is std in. You can nearly just think of this as always being like this until someone else later on teaches you about reading from files on network connections. So fgets is going to take a whole line and dump it in there. So that's actually my input line there. So having done that, this now should have whatever came out of fgets. I'm wondering if there's a nice way to check for invalid input, but I don't think there is. If an error occurs, a null pointer is returned. Ah, okay, good. So, if I want to check if this is a null pointer or not, if fgets this, so if the fgets results in a null, then fgets failed to read. So if it failed to read, I'm just going to say couldn't read input string, and we will return. I think we commented out our return to. It's a similar error though, can't read input. So we will have the same code there. So now, after I've done this code, I should have a line of input inside this array, input line, and in doing that, I will have a word that I want to test if it rhymes with the final line that was in my command line input. So now I'm going to do a similar thing that I did last time. Is still not sure if this is going to be result. Actually, you know what? This isn't going to be an int because I'm going to have a fraction here. So I'm going to have a double. I'm going to call it rhyme score. Is going to be equal to check word instead of check character, and it's going to have two words. I couldn't think of a good way to name these because you're just checking two words against each other, so it's going to be like word 1 and word 2. So this is again me thinking in advance and going, I'm going to have this function that does this. So the first word that I'm going to put in is going to be the input line. And the second word that I want to put in is going to be that same final word of the line that was input. So that was me thinking about this function, check word, and it's going to return a double. So let's create this function. Check word returns a double, and takes in two strings, word 1 and word 2. Let me grab that and create my function. Every time we write a function, we want to talk about what it is, because if we don't talk about what it is, we don't know what we're making and we don't know how to use it later. Checks for how many letters in word 1 appear in word 2, returns the fraction of these letters that it finds. So, for example, if all of the letters in word 1 are in word 2, it will return 1. if half of the letters that are in word 1 are in word 2, it should return 0.5, right? So that's what I'm thinking of for this return here. So double rhyme fraction. I'm going to just make it 0 just in case. I don't know necessarily whether I need that or not. I'm just chucking some enters at the bottom so that I'm working in the middle of the screen here. Do we have any chat there? Oh no, Eric's asking if null is something we've defined. No, but null is something that gets defined in most of the standard libraries. I think most of the time it actually just gets defined as 0. But there's a much bigger implication of how null isn't necessarily 0. Like, I think Shrey has a link to a Twitter thread that talks about it, which is really interesting. I don't know if you've got it there, Shrey. I don't know if Shrey's actually here right now. He may be prepping a tutorial. Okay, so if we want to do the rhyming fraction, then what we're going to do is we're going to loop through one word. I've actually got the code here. Oops. So what we're going to do is find out how many matches we have by running found letter and checking whether they work or not. So we're going to loop through all of the letters of word 1 and check them against word 2. So we're going to use our checkchar function multiple times. So if we're going to loop, gonna do my fundamentals of my loop first. So we're going to loop through word 1. So I'm going to say while, this is going to be a similar kind of loop that we did before, while word 1I is not equal to the null terminator, we are then going to say we're definitely going to run the checkchar function, and we're going to run it on the current letter of word 1, and we're going to check that against the whole of word 2. That's going to give us some result, so we need to actually check that result. So we're going to say if this is greater than or equal to 0. Oh, it's a similar check that we had here, right? If it's greater than or equal to 0. So I could actually do this. If the checkchar is greater than or equal to 0, I don't need that semicolon anymore, then we have found a match. So I might need another integer here. Matches. Starts at 0, so this is something we're going to be counting up as we go along. So I'm going to say we found multiple matches. I'm running out of time. Oh no. I will hopefully I'm going to start coding quicker so I can just show you this working. Okay, so matches adds up like that. And then what I'm going to do at the end of this is my rhyme fraction must be equal to matches divided by length of string. So now I actually do kind of want to know the length of the string. And there's a couple of ways I could do this. I'm going to do this for fun, even though I could do this because I's just gone through the string, so I will actually be the length of the string. I want to show you the str length function just in case. So I want to use a function to find the length of the string from a library. So that's word 1 is the string. In order to call the string length function, I need to include the library where it exists. String.h. Okay. This, and remember, we've done this before, right? Last time we tried to get a percentage value and a fraction, and we had integers on both sides. Even if this is a double, this is still going to be integers. So I'm going to do my dirty trick from last time. and convert this in a hilarious way to a double, so that it then becomes a calculation that will end in a double to go into this double here that I can then return. Now that I look at this whole rhyme fraction variable doesn't really make any sense. It's not really needed anywhere in this code apart from at the very end here. So I'm actually going to remove it. And I'm going to do this. That'll make that work a little bit better. Okay, so I've hit 1 p.m. I'm going to have to end it here. I'm not actually satisfied with this ending like this. So what I might do is I will run this once to just show you some stuff. We're going to talk about some of the issues. And then because I've got some gaps next week where I'm doing some live streams and stuff, I might actually finish the demo there. If you don't want to do anything in week 6, which I fully understand, you can actually continue through the slides because there's heaps more stuff that I was actually wanting to do with this demo. So let's compile this again. Oops. Unused variable rhyme score at line 62. Right. I should actually print out the result of this. My rhyme score for these words is, and we do %LF for a floating point number, and we print out the rhyme score. Okay, let's try this running at least once. So compile that again. /rhymer. Second line of the song. Union's been on strike. He's down on his luck. I'm just doing this from memory. So tough. So tough. I don't know if this is going to be okay with all this punctuation in it, but we'll see how we go. Yeah, maybe that's fine. Oh yeah, I should say, someone's asking, do we have lectures in week 6? I'm gonna do stuff in week 6. It's not part of the content of the course. So they're optional. One of them is entirely going to be on the issue of professionalism. So it's like, how do we actually act in the computing industry, and how do we want to act and stuff? And it's compiled from all this stuff that I've learned from people about how they hire people and things. So it's not really it's not really anything to do with COMP1511, or you could say it's everything to do with the computing degree. So you view it how you want to, but it's not going to be assessed or anything, but it may be assessed for the rest of your life, right? So that's the difficulty. So let's just type in the word rough because it rhymes with tough, and we'll see how it goes. My rhyming score for rough and tough is 2/3. So if we look at this, there's 1, 2, 3, 4, 5 letters here, and 4 of them rhyme. Is anyone seeing the issue here? Wait, David actually said try rough. I didn't even read that, but yeah. Okay, 2/3 rhyming, 4 out of 5 letters matching. Something is wrong. Yes, Josh is saying, shouldn't it be 80%? Yes. There is an issue here, which we will have to debug, but we can't do it today because I've run out of time. So what I'll do is I will schedule a live stream that we will do next week. I will probably do things just in the same lecture times that we're doing. But what we'll do is we'll look at what happened here. So David's saying, is this to do with the null terminator? And Kat's saying, did it check the whole line? What's going on here? So what we'd want to do is we would want to do some debugging on this. So what we're going to do is I'll come back Tuesday next week. So what I'm probably going to do with my live streams is Tuesday next week is going to be just a general Q&A kind of thing, and we'll look at this, but also I will just answer any questions people have on previous content that we've done. So it's just revision, so I will not introduce any new content that will be assessed next Tuesday. That's the rules for Flexibility Week. And then the Friday one will talk about professionalism. I'm actually doing another talk midweek, which you'll see if you're subscribed to my YouTube, because it'll turn up there soon. I'm giving a talk which is like what I call the brief history of video games, where I've got a talk that I set up a couple of years ago. So I'm going to have to add some stuff to that, because since I last gave that talk, both Animal Crossing and Among Us have appeared, so maybe they'll need to be in there. But I'm giving that talk on Wednesday, so if you're in CSE SOC, you may have seen this on the Facebook page already. So if you're interested, you can come along to that. David's saying maybe it's reading something either side, either space at the front or null terminator. Josh is saying, does it give a new line at the end because we press enter? Is it looping? Okay. Oh, in fact, if you want to, I'll show you what happened after we finish, because I need to finish the lecture. People have got tutes to go to and stuff like that. So let me wrap up the lecture now, and I'll come back afterwards and I'll show you what happened. But we won't go fully into detail, but I'll show you what happened with a bit of debugging. Okay, I'm going to wrap up the lecture there, and I will see those of you next week that are coming along next week. If you're not coming along next week, that's fine. You don't have to. Okay, be back in a sec. All right, I'm back. So, rather than saying what happened here, let us look at how we can find this out. So I actually had slides for this. I realized this is what happens when I create new content last minute for lectures, is I haven't necessarily timed it for how long it goes. So obviously that example was too long because there's other stuff that I wanted to talk about. But I'll show you something, but I do kind of want to go over it in detail so it's recorded and lots of people see it. So I will probably do it during week 6. But let's have a look at our slides. So, is everything working or is it not working? Let's look for logical errors. We've kind of looked for syntax errors already by compiling, and I don't think we have any, but I'm not 100% sure because that number is weird. We can look for logical errors also by testing different inputs. So now, at this point, we want to start potentially saying, let's add some outputs. Are there more characters than we intended? Let's chuck some print statements into these functions to say, okay, these are the things that we're doing. So we can put something in saying what the 2 words are that we're checking to see if they're the correct words. And we can also put something in the check, I called it check char, and see whether they see whether those are the correct characters. So we could just try one of them to begin with, something like this. So this is me saying, I don't know. Like, I don't know if you know the answer already or not, whether you can see it. I know what it is going to be because obviously I set this up so that it would fail in a particular way. But I don't really want to say this is the answer. I want to say, let us find a technique which will get us closer to the answer, and then we'll see what happens, right? Okay, so let me print out checking a certain character against a certain word. And the character's input char, and the word is word. So the %s allows me to print out a string. If I wanted to, I could do fputs or something like that. But let's do this, and this should show us a whole line of things that it's checking. Because I don't want to say what's going on. I know what's going on, but I don't want to say. I just want to check it. It's more important, I think, to learn how to find out information than it is for me to give you answers. I guess I could put something here as well. Oh, no, let's just go for this one thing here and see what it says. So we're going to compile that. We need another line of the song here. Is it Gina? Gina dreams of running away? Is that a name? I wonder if I'm on a different song here. Was there a different song with other characters in it? I don't know. The 90s were a long time ago, and they blend together. So Dan's saying, Mark, can you quickly summarize the code? Like, what happened to the input each part? Lose track of what happened. Okay, we will in a second. I think there's people waiting to see what happens here. What is it? Tommy whispers in the night, baby, it's okay, it's okay. So the rhyming word is okay. Point 4 with a 4-letter word doesn't seem to add up. Checking O-K-A-Y. Hello. Hello. Oh, okay, someday. Oh, Ethan knows the lyrics. That's a stain on your reputation, Ethan, that you know the lyrics accurately to this song. But our testing has revealed something. We are testing an extra character. That character appears to be whatever character is in that space there, which is a new line. So we are accidentally testing a 5-letter word with a new line on the end instead of the 4-letter word that we intended, because fgets was going to grab every character we entered on that line, and every character we entered on that line includes every key we pressed, which is the enter key, which was pressed on that line as well. So that's interesting, isn't it? And then I'm not going to do it now because it will take time, and also it's something that that I probably want to do when more people are around. So we'll have a look at that on Tuesday, where we will complete this. And so we'll say, okay, looking at this testing, looking at methods to remove the new line from the end, and then we finish. So I think I need to recalibrate this lecture example to be a bit shorter. Maybe I won't do this single input thing at the beginning, although I thought it was useful to build that up. What I need is all my lectures to be longer so that I can talk for longer, but then I think I will end up just talking about random stuff. So, any other questions about what we did there? Okay, I'm going to go back through some of the questions that we've got. There's a question from Josh. Does it give a new line at the end because we press enter? The answer to that was yes. And we found that out by trying to get more information from our program. So it's always, when things are going wrong, handy to just find places to get more information from your program, and then you'll know for sure. Rosie's saying, why don't we need to also multiply string length word 1 by 1.0? So where were we using those? Here. So when we divide two numbers, this is actually like just sort of like the rules of C. It's just like this underlying stuff. So there's no logical reason why this is the case, but C is okay with if one of these is a double and the other is an integer, it will retain the sort of minimum level of information necessary from the variables that went in. So the double says there is a double in this division, therefore I require you to maintain a double level of precision in the result. So it only needs one double to hold it to that level. So we don't actually need to do both. And someone else was asking there about casting these things. Casting is a different technique, which we don't teach explicitly in COMP1511 because it comes with its own set of complications and things. And casting does this. I'll show it to you, but we're not necessarily going to use it. Where it does this and it says, this variable, please read it as if it's one of these. And that will do the same kind of thing. But it's got all these kind of continuing ramifications of things, and if we're not going to teach all of that, then there wasn't really space to do that. Instead, what I did was just use only the techniques that we have available to us at this point to convert that into a double. So Dan is wondering, can we quickly summarize the code, like what happened with the input with each part? I lose track of what happened. Okay, so let's... Gira-chan says 24-hour lectures. That would be pretty funny, and like at some point I'd actually be up for that. I think what thing would be really, really funny is if we did like a hackathon style thing where like it's actually just 24 hours and I will just teach continuously for 24 hours and then like have breaks for random stuff. Like it's like, okay, I'm bored of teaching. Let's play some games for a bit and then like come back and go, okay, this is the music. And then, okay, so we're going to listen to some music and we're going to freestyle rap to it. And then we're going to go back to coding. Or just like, I should pitch that as a summer session course. Because those summer session courses are so fast. They're like 2 weeks for this entire course. I'm just like, that's not going to work. Like if I taught COMP1511 in 2 weeks, I think some of you would be like, wait, what's an array? And I'd be like, oh no, that was 3 hours ago. We're gone. We're past that now. We're in like pointers in 2D arrays now. We've got a 2D array of pointers here. Why aren't we already on this? Like, I think that the human brain needs a certain amount of time to, without me talking at you, a certain amount of time for you to sit and process and think about these things on your own. So I think we would kill people like that, but it would be kind of funny to do a 24-hour lecture. As David said, your brain would be fried. Okay, so Dan had questions about input. Let's go through and look at how these things are working. So, the argc and the argv are two variables that are created as the program begins. They are created by the stuff that is actually typed in on the command line. So, to make this easier for you, Dan, and also I think this would be good for everyone, let's just add some stuff in here. Printf. There were a certain number of words on the command line. And that number is argc. The name of the program is... I can print out a string. argv0. We're assuming that argv0 exists because we didn't get this. Having said that, argv0 kind of has to exist. It's very hard to run a program without having typed it in, although it is possible. Right? I don't know how this would work, but if we just go to the file and double click on it, then there's no command line input. So I don't know if argv will exist at that point, but we'd never get to there because we'd trigger this in that case. Okay, then we say another printf the words are going to be more detailed than that. The rest of the command line arguments are, and then we're going to loop through these, starting from 1 because we've already used 0. While I is less than argc, because we know argc is the count of the arguments, the number of arguments. Printf. Oh, I could do this with an fputs. I'm just going to start using all these extra library functions so that you at least see them. You'll see them at least once, right? Argv I. And we say, wait, how does fputs work? I just kind of want to show you this, right? Even though I kind of know how these things work, I think it's better to be like, okay, what would I do if I didn't know what this was? Fputs in C. I had an autocomplete for it there. Fputs takes a string, goes to a stream, writes a string to the specified stream, up to but not including the null character. So they're calling it a null character, the null terminator. So I have the string, and the stream is going to be standard output. Oh wait, they've got something else. Let's not look at the example where they're doing file input output. Standard output. Oh, we probably want spaces between these. Oh, you know what? Fputs. No, fputs. Putchar is the one I want. Putchar. The space. Okay, I'm just using the library functions just so that I can show you the library functions. I could have done all of this with printf, but I want to show you that there are other options. You don't always have to take the other options, but I want to at least show you. Okay, so this will tell us about what our command line input was. So we're going to run it. Gina dreams of running away. Tommy whispers in the night, baby, it's okay. What was it? It's okay someday? Someday. Wow, I've been singing that wrong for a good 30 years. Oh well. Oh, oops. Something in what I wrote there. I knew that this was potentially going to be a problem. Is that I'm going to say one of these, but it's weird. I've got them here. That one of them was going to be a code thing for the terminal that meant something else. So I'm going to control C out of that. I don't know which of those. I don't understand why, because I know that apostrophes and commas can sometimes throw off the command line args. Oh, yeah, why would Tommy whisper? Oh, good, Ethan knows all the lyrics here. This is good. So this is obviously that when I've been singing this, I haven't, I've just been singing random stuff and waiting for the chorus to appear. Okay. Gina cries in the night. So I'm one of those people that just pretends they know the words. And then when the chorus comes up, I sing it really loudly. I'm going to take out the punctuation because I think the punctuation caused that. Baby, it's okay. I'm going to just go with that, okay. Oh, oops. Did I leave out my I++ again? Again. I did. Okay, try this again. You can tell that I have a limited amount of effort that I can put into my teaching, and it goes in a 2-hour increment. At the end of it, my brain just goes, okay, you're done. Stop thinking now. Okay. There were 11 words on the command line. Name of the program is Rhymer. The rest of the command line arguments are Gina cries in the night, Tommy whispers, baby, it's okay. And then we go on to the rest of the program. So, what we see from this output here is that the argc will tell us how many things were on the command line, and the argv is an array of strings, and I'm looping through that array and printing them out one at a time, and it will be exactly the stuff that I wrote there. So there gets output again there. So we can see that that input that went on the command line is available to us inside the program. Then we had a bit of an exercise there about taking a single character as input, and then I replaced that with taking a string as input. So here we have creating a string. This is an empty string of maximum length. And an empty string of maximum length just means that I've got space to store something. And then I called fgets inside this if statement here. So this is a function call, and I put a function call inside the question of an if statement, which I'm allowed to do because in the same way that I could have is A plus B greater than C, I could say that you have to evaluate one side of this thing before you can check the equals. So if we have to evaluate, sorry, pronounce that correctly, here, this means this function runs, and if the result of the function is not null, then we go on. But that doesn't mean this function didn't run. This function did run, so fgets takes a line of input, and it puts it into input line, and so long as it ran correctly, we can continue. So this means that in input line is whatever I type in after this. Please type in a word to rhyme. So here, typing in a word to rhyme, I can't remember what rhymes with okay. Oh, is it away? It's the previous line. So this fgets here will put the word away into this array of characters here. So this array of characters now has the letters A, W, A, Y. It also has the enter key. It also has the new line because fgets picked up our new line there as well. And we know it worked because we didn't get the message saying it couldn't read the input string, but it did start going through and checking things. So check word calls, check character multiple times, which is why we see check character multiple times there. Dan, is that giving you more information about the inputs and outputs? I'm using some library functions here to do stuff. So you could consider this fgets to be a little bit similar. It's not the same, but a little bit similar to me calling scanf and saying, take in some input and put it into this line. So fgets and scanf are not the same because scanf says, I want input in a particular format and I can deal with numbers versus characters versus other things. Whereas fgets says, I don't care what type it is, I'm going to take it all in. Right. So fgets is nearly more of a, we're guaranteeing that we're going to take the input. Scanf is going to reject the input unless it's in a particular format. So if you say, I want numbers, it'll only read numbers. If I want characters, it'll only read a single character. Whereas fgets, it says, just give me whatever you've got and I'll deal with it. To the point where we took our enter key. So we took everything, including the enter key, and then we have to deal with it later. Dan, yes, you're definitely going to go deeper into this in your tutorials and labs. There is no tutorial and lab in week 6, which is next week. So just remember, next week, flexibility week, less stuff happening. My weekly notice on Sunday will remind everyone of that as well. And week 7 is where we will have the tutorial and lab that goes over this stuff. So I think it'll probably be pretty good that if you're not sure of things, turn up again during week 6 and we can go over these kinds of things. I'll do a Q&A, that kind of thing. So that way it's still fresh in your mind when you get to your tutorial in week 7. All right, I'm going to wrap it up there because we're 1:30. It's long enough. I will continue this next Tuesday, but you don't have to be there if you don't want to. But if you want to take part, that's totally cool. I've got no problem with people wanting to do that. But it'll be a little bit of this, but also just like I'll answer any questions people have about the course so far and what we've got in the course. So it'll be more of a genuine live stream than a lecture. But at least the rest of this example will be recorded then for people to watch afterwards. So you don't have to, like, what I'm trying to say is that, like, Stuff in week 6 is optional, so you can choose what you want to do. I will let you know exactly what the timetable is for week 6. All the content that's coming out in week 6, none of it is accessible, so it's not really that big a deal. If any of it is part of what we'd consider accessible content, it'll just be a revision of stuff I've taught you before. So there's no new topics introduced in week 6. There's also no weekly test deadline in week 6, but we will be keeping up all of the help sessions because the assignment is due at the end of week 6 anyway. So it's kind of like, I apologize, I'm exactly that meme that I saw on the UNSW discussion Facebook group, which was just like, hey, have a flexibility week. Here, have 8 assignments to finish. And I was like, I'm sorry. Yes, I'm one of those. But yeah, we'll be keeping up all the help session and forum support during the week, so you don't have to worry about doing lab exercises or the weekly test or anything, and instead you can just focus on the assignment in that time. All right, my voice is done for the day. I should wrap up. Thank you all, and I will see whoever's interested in coming along next week, and I'll let you know what's happening, and the timetables for stuff. All right, see you later, everyone.